So I think I stole the blind people or blind men and elephants thing from Seth Lloyd. So thank you, Seth.
I made it up myself. Yeah.
Yes, I'm very impressed. So I think it's actually a fitting metaphor for the conference. Of course, if you're not familiar with it, it's an old, I guess, Hindu story, although I guess it appears in many Asian cultures, and it has to do with, if you put a bunch of blind people in front of an elephant and they sort of start touching it, they all sort of think it's a different thing. So the guy touching the trunk thinks it's a snake, the person touching the tail thinks it's a rope. And I think that's kind of certainly was appropriate for our first session, which was sort of what is information? And we had lots and lots of different answers. It's means relative, it's relational, it's semantic, statistical, observer dependent, task-oriented, quantum, indexical. There's actually a theme here, and I think the rough consensus, at least in my view, was that it was contextual in some sense. So information seems to be a relative, subjective concept. And I think, I was looking for the right word, and I think contextual kind of is probably the best thing. I think the most general word that covers all of these ideas, in the sense that information depends on the context in which we analyze it, which is really kind of interesting, because I think it was Olympia Lombardi who actually said something to the effect of, why can't we just have like 15 different definitions or something like that, right? You said that? Didn't you say that? Something like that? There's no reason why do we really need one definition? I will say, I have a tendency to think that we do need one definition. Ooh, I got rid of that slide. There was another slide in there, and it was going to say that there's a physicist by the name of Herb Bernstein, whom some of you know, and Herb wrote a book with a guy named Mike Fortune, I don't know, 15 years ago, and what they said was that words matter, and so while I think it's okay to have 15 different definitions, we have to be careful that we know what we're talking about, because at the last FQXi conference, we were talking a lot about entropy, and I thought a lot of people were using they had different ideas of what entropy meant. And at least this time around, everybody recognized that, and they said, well, so we have all these different types of entropy and information, but I think there was a consensus that it was contextual. So if there's one theme tying it all together. So some further thoughts on information. Paul Davies said that determinism must be emergent, since purpose-driven ideas arise from randomness. There was this, so Andrew Hamilton and Don Page, I think, and by the way, if I label your name with a concept that you didn't come up with, just shout me down. I did this at 3 in the morning, so I could have gotten it wrong. They maintained that conservation of quantum information was a rather bold claim. As a quantum information guy, I'm not sure I agree with that, but that's, neither here nor there. Christoph said we needed a calculus of information, kind of like a semantic calculus. And Wayne Mervold said, should we instead be comparing theories as opposed to falsifying them? And then Fred Adams said that information content is not equal to complexity. And that's an interesting idea, because that arose at the last FQXi conference, where we were, several people, Sean Carroll and Scott Aaronson and others, were talking about how you have entropy of the universe, which is always increasing, but then the complexity of the universe seems to be increasing and then decreasing. And if complexity is information, then you have sort of a problem there. But information content is not equal to complexity. They are distinct concepts. So, and then Marcelo asked, "What is knowledge?" which I thought was a fascinating question. I think so. You have information content. You have the materials with which information is made. So the matter and energy that is used to encode information. But then you have our knowledge of information. And the measures that we use to make measurements of information, well, I'll be giving away some of the bias that I have being a quantum information guy. So to me, these measures are measures of our knowledge. So that certainly, you know, I'm a Bayesian, so, you know, that's kind of how we interpret things. So you know, the question is what is knowledge? And knowledge it's not exactly the same thing as information itself. So that's an intriguing question. So those were some of the further thoughts that were shared at that first session. Yeah, right, and Giulio Tononi said we need a maximally irreducible conceptual structure, which is to say that if you have a system and the sum of its parts don't give you any more information than the whole, or the whole doesn't give you any information than the sum of its parts, then they're equivalent, and there's no reason to even talk about any difference there. So then we had breakout sessions on Monday. Being that I was unable to be in a quantum superposition of like 8 different things, I was in only one, which was the first one. Well, you know, I didn't want to give away all my secrets. Right. Well. See now, Max, you believe in the multiverse. So, in another universe, I was actually in every single one. So. So in some other universe, I'm actually giving a different talk. But so in the one I was in, we were looking at whether information is whether it's more fundamental than matter and energy. And what was rather surprising, actually to myself, I was surprised at my own answer to this. The consensus was strangely that it's probably not more fundamental than matter and energy, but something is. And we couldn't really agree on what that something was, but it was proposed that perhaps Max Tegmark is more fundamental than matter and energy. So there was a session on quantum information. Does quantum information, is it required if you're going to understand quantum gravity? And the takeaway, and of course I wasn't in that session, at least in this universe, and what I could take away from the things that were presented, that group gave Scott Aaronson the job of presenting, and he said he showed up to the group and said, well, duh, yeah, and then went swimming. So, and no one seemed to disagree with him. So I guess that question has been answered. Quantum information is clearly necessary for an understanding of quantum gravity. Period. So, if you disagree with that, hunt down Scott. Okay, Anthony disagrees.
Well, that was our panel too. The more subtle conclusion before it got swimming was that it was obviously useful, but obviously not necessary.
Oh, okay. Well, I see. All right. Take 10 points off my grade for that. All right. Wasn't paying attention. There was one on complexity versus information. And the idea is complexity vis-a-vis information about a structure. So if we define complexity to be information about a structure, it's not information itself. And of course, I think Fred Adams had said that in the first session, and I made a point of that on a previous slide. So that's what I took away from that particular session, which I wasn't at. So if anyone has any objections, no? Okay. So. There was one on whether information was conserved in isolated systems, and the consensus that I got was that it's conserved in isolated systems, but it's dependent on how the system is defined, which is such a typical response from physicists. Well, how do you define it? So I can't give any a whole lot more insight into that because I wasn't there. Will physics eventually be able to account for consciousness? The consensus from that group seemed to be that yes, it will eventually. Although I guess there was at least one notable dissenter. I don't know if the dissenter wishes to raise their hand, but aha. Oh, we have two notable dissenters. Aha, okay. So there were two dissenters on that, which is interesting.
That wasn't quite the conclusion of our group. Yeah, that was not quite the conclusion.
Well, I don't know. Was that your group?
Yes, yeah.
Okay. So, that's what I wrote. What was the conclusion of your group?
Well, we all agree consciousness exists.
Yeah.
We all agree it's important. We all agree that physics probably plays an important part, but it's well possible that physics has to be extended, or physics has to be extended in a lawful way in order to account for consciousness.
Okay. Isn't that, well, even if you're extending physics, it's still physics, right?
Yeah.
Right. So physics can and will eventually account for consciousness. Depends on how you. Okay. Well.
But not present-day physics, I guess.
Well, I didn't say present-day physics. Physics.
Depends on how you define it.
Okay. So anyway, are there limits on information storage and processing? Yes, there are. Spacetime itself was an example. There were more than 6 breakout sessions, but I didn't have data from all of them. So are there any that I'm missing? Anybody want to jump up and say, yes, you forgot my group? Don't be shy. No? All right, well, maybe I did get them all, because I think that's all I had. All right, so anyway, we had an evening session on what is quantum information really good for, which, thanks to Anthony, I then had that song, what was that, Sly and the Family Stone? What is it really good for? Stuck in my head. Well, it's certainly good for relationships, but certainly not for fixing the Wi-Fi. So, at least not yet. So, does anybody think that Anton Zeilinger looks like a, I don't know, like a guy from the Imperial forces in Star Wars? Admiral Zeilinger. Anyway, so what is it really good for? Well, certainly, it was hard to get a consensus. You know, I couldn't find a buzzword for this that said, yes, here's the buzzword that everybody agreed on. But I'll just summarize a couple of the points that were made by different people. One is that randomness is the strongest evidence of the outside world, since it limits our ability to control the outside world. And this limit is related to our choice of the apparatus. But there are really 2 freedoms. Our choice and nature's. This was actually something that Admiral Zeilinger said. And then there was a little debate about what he meant by nature, because he kind of imbued it with the... no, I don't think he said he or she, but there was some debate about whether, what he meant by that. And he said, well, it was just a colloquialism. So, but he said that the 2 natures are, the 2 freedoms are nature's, our choice of what apparatus to use to ask the question about nature, and then nature's freedom, if nature has any freedom or free will, to randomly answer the question that we ask. So, does information actually have causal power, or is it merely explanatory? This is a question that Andrew Briggs asked, and actually I should say this has been an interesting conference, because a great number of us got stuck somewhere because of an ice storm in the Northeast. And strangely, even though I live in Maine and left on Sunday, I had no trouble whatsoever, which is very odd. So Andrew Briggs had to take the place of Ray Laflamme because there was because he was stuck. So this is actually a question from Andrew Briggs. He was originally supposed to be in the morning session the next day. But I thought it was a great question. Does information actually have causal power, or is it merely explanatory? Can information actually lead to some kind of causal is there a causal chain of events that you can string up with information? Again, as a quantum information theorist, I say, well, yeah, but it's on a more macroscopic scale that may not be as obvious. And then Gerardo Odesso talked about correlations. He said correlations are general, and there are subcategories of quantum and classical. And this relates to some other ideas that people have been working on in terms of quantum mechanics being like a general, a specific case of a more general probabilistic theory. So these were sort of some ideas that came out of the 3 talks that night. And then I thought this was interesting. So Zeilinger said quantum mechanics, and I never knew this. I've known Anton for a couple of years, and I never really, this was kind of funny. He said quantum mechanics was invented to explain nature. I thought that was fascinating. But then Gerardo said that there's actually a way to identify quantumness, which is interesting, because if it was invented, then how could you identify it? So I thought that's an interesting contrast between those guys. So then there was a session on measuring and manipulating information, and for all of those of you who are about to board a plane back to the frigid continental United States, I included a picture of a ruler in snow. If you can't read it, it's 13 inches, or just under 13 inches, which is a heck of a lot less than I have at my house, but anyway. So in this session, some of the takeaway points were our level of control over quantum systems has dramatically increased in recent years. So this was actually came from Raymond Laflamme's talk on quantum error correction. So it's funny that he got shuffled to this session, but I thought it actually fit pretty well. He talked about quantum error correction and some of the and even outside of quantum error correction, there's a tremendous amount of control that we've developed over quantum systems in recent years, and the amount of control that you need to be able to work with a quantum system is just phenomenal. And then Scott Aaronson said that, well, the Church Turing thesis is on solid ground, and he likened any objection to it to people who constantly come up with perpetual motion machine ideas. But, and there's a but here, there's always a but, if the universe is mathematical, then Gödel's theorems must apply to quantum and computational systems, Max. So that's what's that?
Why is that a but? Why are they even
I liked the word but, and it was 3 in the morning. We could debate whether that's a but or an and or an or a I don't know. But there it is. It's a but today. And it's a but with 1 T, not 2. So so those are some takeaway points from the measuring and manipulating information session and the talks in that. Information and cosmology. Okay, so I struggled over this, and you got to remember that it was 3 in the morning. All right, so and so it begins. This was an interesting one. Do quantum or thermal fluctuations only happen when you look at them? This is a claim that Sean Carroll made. So I was struggling to think about this last night, and I kept trying to think about, all right, what kind of analogies can I come up with? And of course, I'm not sure these analogies are really right. But what Sean was saying was that, if I'm getting it correct, Sean was saying that the thermal fluctuations in quantum systems only come about when you actually, you have to get it into an eigenstate. And when you repeatedly get the system into an eigenstate, you get, different random results, and that's your fluctuation. And I think I think that's a reasonable characterization of what he was trying to say. On the other hand, I would say most, and I should just mention briefly that he put up a picture that was taken this year of an electron orbital in I think it was a hydrogen atom or something like that, as evidence that the wave function, we can see the wave function all at one instant. I have some possible philosophical objections to that interpretation of that picture, but nevertheless, he put it up there. So, it was an actual picture. Well, no, I'm not. I don't philosophically object to the picture. I philosophically object to the interpretation of the picture. So, but at any rate, so the other way of looking at it, so I would say that the traditional view of quantum, and again, these are technically really we're talking about the thermal fluctuations here, is that they're actually always happening, so that these quantum systems are constantly flitting in and out of states until you measure them, and then once you measure them, the fluctuation stops. So those are two sort of different ways of looking at it. I just threw Schrodinger's cat up here because it was 3 in the morning, and everyone likes a picture of Schrodinger's cat, even if it really doesn't apply to anything. But anyway, so I think those are the two arguments. I'm hoping that I successfully summarized the two competing viewpoints there, and I think it's an interesting debate to have. I tend to disagree with Sean on this, but I can see where he's coming from, I think. So those were, and that this led to quite a debate, which is why I had "and so it begins" up there. So what it really is it's a debate over the interpretation of the wave function. At least that's my opinion, but I think it really boils down to an interpretation, a debate over the interpretation of what the wave function is, which is an interesting debate, but it's also one that's been going on for a very long time, and we still have no consensus. So we're probably not going to make a whole lot of progress on that one. Anyway, some other things that were discussed at this information cosmology session that were maybe not quite as controversial were if maximum entropy is infinite. I think Alan Guth said this, then any realistic entropy is going to be low. So if you have a number that's infinite, then any finite number is going to be low compared to infinity. And so if the maximum, and this goes back to a debate that was at the last FQXi conference over the problem, the fact that there is a lot of people see the low entropy early universe as being a problem. And Alan's approach to this is to say, well, if the maximum entropy, meaning if the universe is just going to always expand, and so the maximum entropy will be infinite, then any realistic entropy is going to be low. And so if we have a finite amount of it now, then it's going to look low compared to what we could have. And then one of the questions that was asked is, how can we compute a probability in an infinite universe? And then Anthony decided to be provocative. Oh, and he just got up and turned his back to me. Oh, well. His first provocation was that there is only indexical information. I didn't really see that as provocative, but actually thought that was really cool. But his second provocation is that an infinite universe and a really, 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 really big universe are not observationally distinguishable. Did I get that right? Is that your? What did you? It was the opposite of what? Or not distinguishable? No, are distinguishable. May be distinguishable. Okay. All right. So strike the word "not." So it really was what I read onto consciousness, which I have to be honest. I love these sessions. These are really cool. The consciousness stuff is wicked cool. So the rough consensus that I got, correct me if I'm wrong, is that it's macroscopic and it has degrees or levels, so that it's sort of, I guess you could call it an emergent property. I'm not so sure if it's emergent in the same sense of space or time or something like that, but it's macroscopic, but it has degrees. So for instance, we're more conscious than, say, a goat, maybe. I don't know. So what are some of the undeniable fact is if we know we are conscious. This is something that goes back hundreds of years, unless, of course, you're Giulio Tononi said he had a patient who, honest to God, believed he didn't exist, which is fascinating. I guess this is a known thing. Chalmers's hard problem was, how does matter and energy then give rise to consciousness? And this is sort of the big, I guess, one of the big questions that has been, or is attempting to be addressed. There are, one of the things that I learned, this is really cool, there are now empirical ways to determine consciousness. Christoph, I think, talked about some of them and some of the things he's doing in his lab. The interesting thing is that conscious and unconscious, again, this goes back to how we define it, but conscious and unconscious systems can be functionally equivalent. So, for instance, an inactive system can be conscious, but information does not necessarily have to be exchanged for it to be conscious, which is an interesting idea. And lived experience plays a major role in defining consciousness. So, defining what it is very much related to how the conscious entity experiences the world. And Max was provocative and said it may be a state of matter, which is a really interesting idea. That would certainly introduce new physics. So some further thoughts from that session. There are levels of causal analysis that are based on their informativeness. So obviously, consciousness, there's some kind of relation to the causality here, and there's causal analysis, and there are levels of this based on how informative they are. And consciousness is sort of equivalent to the information at the macro level, meaning it's not equivalent to the stuff per se. It's equivalent to information at the macro level. So then we got into talking about free will. Their biological basics and definitions and things were given in some talks. Life is about a pattern, how the information is organized. It's not actually the stuff that goes back to what I just said about consciousness. It's about a pattern. So it's basically about organization of information. Lots of things in our bodies are not in thermal equilibrium. Free will, and I think this was said about consciousness too, it's a consequence of lived and remembered existence, which is kind of similar to the idea of a lived experience. So it's interesting that free will and consciousness are so closely aligned. Well, I guess it's not that interesting, but their definitions are very closely aligned. Somebody said it was a necessary illusion for life. I thought that was interesting. That free will is a necessary illusion. There's at least one person I know who's not here who's very much into the fact that free will does not exist, and we don't actually have any free will. Nevertheless, there is evidence that it does exist, and it comes in our inability to predict behavior, which is kind of funny that you would think that, but it makes sense because if the universe were perfectly deterministic and you could predict all the behavior that there is, then you wouldn't really be making any free choices. And so that's why we say it's sort of related to our inability to predict behavior. So some general thoughts on this. There's a lot of progress on free will, not just related to the typical questions, but I think related to all of this, the problem that was brought up is, what do we tackle first as a question? Do we tackle the origin of life question? Do we tackle the origin of consciousness question? Do we tackle the free will question? Obviously, I think the answer is probably that all three are going to be tackled by different people depending on what they're interested in. But it was an interesting thing to somebody pose that question. What's better to tackle first? Which of those three questions? Okay, quantum gravity. So then we somehow went from all of that stuff having to do with the brain to quantum gravity, which may or may not have anything to do with the brain. some of the things that, and now I have to admit that some of this is one of those sessions that sort of ended up getting very, very technical after a while. Two of the things I picked up were that from Carlo Rovelli's talk, temperature at equilibrium is not a constant in a gravitational field, but the information is, so he's able to preserve the zeroth law of thermodynamics, which I thought was really cool. And then Seth Lloyd gave us some advice that if you fall into a black hole, don't struggle. And then the other part of the talk was Firewalls, Raphael Busso versus the world. Except maybe for Seth Lloyd and Don Page, who I think came to Raphael's defense at some point or another. I'll admit that I was lost in some of the technical details. I'm not very knowledgeable about some of the details of this stuff, but according to my notes, there was a majority that said firewalls don't exist, but there's no agreement why. I'm sure if I asked that question again, I'd get a different answer. But at the time, I wrote in my notes that the majority said firewalls don't exist, because I'm pretty sure that Raphael says they do exist. No? Okay, well, see, there you go. All right. Well, you know, I mean, like I said, that was a fascinating session, but the details got to the point where I was like, yeah, all right, I'm not quite, you know, I haven't read those papers. Am I correct in saying that a slight majority believes that they don't exist?
We don't have clickers, but
Uh-huh.
raise your hand if you think firewalls don't exist. Okay. Raise your hand if you think that they do exist.
Oh, it's more than a slight majority. It's an overwhelming majority.
Raise your hand if you didn't raise your hand. So that there's a lot of undecided also.
Oh, so there's some undecided. Okay, all right, very good. All right, so I was right. I was right there. Okay, but I was wrong. I was wrong on. I guess I was wrong on Raphael's thing. Well, anyway, but he certainly, it was a contentious. Oh, see, Raphael has his hand up. Go ahead.
Can I call for a vote? Which of you believe that they actually understand the argument for why firewalls are necessary for unitarity?
Can you repeat the question?
He wants to know which of us. Yeah. Why did you vote the way you voted? But we can ask that later.
Well, it it's always understood. Most people believe it didn't exist, but they didn't know why it didn't exist.
Right. So, all right. So there we go. So everyone.
Just to make everybody feel good, I mean, raise your hand if you feel you completely understand what's going on with black holes. Wow.
Chris Adami has his hand up, just so you know. Okay. I'm going to the beach with Chris later. I'm going to ask him about that. Anthony wanted to know the source of Hawking radiation, which was just getting an answer to that question was like pulling teeth. Everybody wanted to turn the question to something else, and he said, I just want to know, what's the source of Hawking radiation? After much coaxing, the answer was that whatever it is, it's physical. So, not much of an answer, but c'est la vie. So that's what I took away from that session, which is a session that, like I said, I don't have a whole lot of experience in, so I did the best I could. So then we had a really interesting session yesterday on existential risk. And some of the ideas that came out of this session of what were some of the things that pose an existential risk to humanity. And things like global warming and biotechnology, AI gone bad, like the Terminator. These were all raised, decline of biodiversity. I propose that the common theme here is that it all traces back to us, and that somehow we are responsible for our existential risk. You know, so the greatest risk to our existence is us. That's my way of sort of interpreting all of those things, because all of those things are a direct result of things that we're doing. There were a few people who said things like, you know, a rogue comet and an asteroid, which certainly are, after what happened in Chelyabinsk last year, it's, you know, it's certainly a real risk. But I think some of the ones that are certainly the ones that were most popular with the panel and with the audience all had a common theme, and that was that you could trace them back to something that we did as human beings or are doing. So the question is what can we do about it? Well, certainly FQXi can help by formulating the questions surrounding existential risk, which I think yesterday we took a step in the right direction by doing that. And then I think it was Jan Tallinn who had used the term effective altruism to talk about another way that we can sort of help to mitigate existential risk. I personally, and I think, I know Max said it too, I think that the root of all of these problems, if you want to solve any of these problems, you have to at least take education into account at some level. Education, because if people are ignorant of the problems, and when I say ignorant, I don't mean ignorant, and to me that word is it's just a statement on a state of knowledge, not the ability to know. So it doesn't mean that a person is unable to know. It just means that they don't know. So I'm ignorant about black hole firewalls. So education, we have to educate people. Of course, there's an awful lot of debate about how to do that. So I don't think there's any debate about the fact that education is at the root. The question is, how do we do that? I think we can learn a lesson from religion. This is just my personal take on it. We need to learn, as scientists, genuine empathy. We need to be able to not look down at people who think differently than us, and we have to take their concerns into account. So I'm using this as a bully pulpit here for a second to say that we have to recognize that whether we agree with their concerns or not, they are their concerns, and by just dismissing them, we're certainly not going to make any friends, and it's not going to help our cause. And sort of somewhat related to that, science communication is a two-way street. So as scientists, one of the things that we do to try to help get the word out and educate people is that we communicate. And we communicate by working with science journalists and stuff. But science communication itself is a two-way street, and we have to remember that. And that's the point. You can't walk into some place and just say, this is how it is, and there's no questions here. You have to actually engage with your audience and be responsive to their needs and their questions. And finally, I think more than one person said that one of the things we have to do then to really do this is change ourselves. So the last bullet point I had on my last slide was that the greatest source of existential risk is us. And so, well, what can we do about it? Well, we have to change us, ourselves. So I'll leave you with that. That's a picture of Hofstadters' butterfly, which was predicted in the 70s, a beautiful thing. It has to do with electron structure, and this is in graphene. And it's an interesting combination of beauty and science. So I'll leave you with that.
Thank you. Let's thank Ian for this really wonderful job you've done summarizing, very hard to summarize